n here is a complex number. And given this equation, n plus 1 over n equals negative 1, then our goal in this question is to find the numerical value of n raised to 99 plus 1 over n raised to 99. Pause the video right now and see if you can answer this kind of question. And of course, if you're done, post your answer in the comment section down below. Now, let's see if you got the correct answer. Alright, so from here, we know that n is a complex number that satisfies this equation n plus 1 over n equals negative 1. Then the main goal is to evaluate n raised to 99 plus 1 over n raised to 99. Alright, now let's answer this question. First, let's get our given equation n plus 1 over n equals negative 1. Now, in this equation, since n is in the denominator, so we can say that n is not equal to 0. Otherwise, this equation is invalid because we have 0 on the denominator. Now, let's set aside this note that n is not equal to 0. We will use this later on. Now, what we're going to do here is to multiply all of this term by n. This is allowed because n here is not equal to 0. So, we have n squared plus 1 equals negative n. Now, rearrange some terms a little bit. Now, let's focus on this result. And then, we will multiply again by n on both sides because we know n is not equal to 0. Here we go. So, we have n cubed plus n squared plus n equals 0. But, we can find the value of n squared plus n. So, using the first equation or the original equation, if we subtract 1 on both sides, we get that n squared plus n is negative 1. So we can replace n squared plus n with negative 1. And from here, if we add 1 on both sides, we get that n cubed equals 1. Now here comes the confusion in this kind of question. Someone in the comment section will say, n here is 1. If we cube on both sides, we get n equals 1. And 1 doesn't satisfy this equation n plus 1 over n equals negative 1. Of course, n equals 1 is one of the root of n cubed, but not necessarily the value of n. Because on the original equation, n here is a complex number. You can use quadratic formula and solve for the value of n. And here, n cubed equals 1, we have 3 possible values of n, and 2 of those roots are the real value of this n, or the value of n that satisfies this equation, n plus 1 over n equals negative 1. But if we cube that value of n, that complex value of n, we end up with n cubed equals 1. So 1 here is not necessarily root of n plus 1 over n equals negative 1. Alright? Now, we will use this concept to answer this question because we know n cubed equals 1. So, if we raise both sides by 33, we have n raised to 99 equals 1 raised to 33. And 1 raised to 33 is just 1. Now, we know the value of n raised to 99, which is 1. We can now evaluate our expression. So, we have n raised to 99 plus 1 over n raised to 99. We know this is both equal to 1. So we have 1 plus 1 over 1, or simply equal to 1 plus 1. And 1 plus 1 is simply equal to 2. Therefore, given that n is a complex number that satisfies this equation n plus 1 over n equals negative 1, then the numerical value of n raised to 99 plus 1 over n raised to 99 is simply equal to 2. And as always, we are done.